is about water management. We're going to discuss the adequate management of tailings disposal is to talk about adequate management of water that is used. A common denominator for most of the failures of tailings dams in the recent decades has been inadequate water management. This panel will talk about this. To interact with our international speaker, I'll invite onto the stage Geotechnical Senior Manager of Mosaic Fertilizers Brazil, Thiago Moura de Queiroz e Oliveira. Online, our speaker, Caius Priscu, Joint Professor of the Canadian Institute of Mining Engineering. He is co-founder and main geotechnical engineer of the University of British Columbia in Canada and associate of Prisco consultant engineers in Canada as well. I'd like to thank you for being here, Dr. Priscu, and pass the floor to Thiago, who will chair this session. Thank you, Marcílio. Good morning, everybody. First, a few words in Portuguese, and then to better interact with Dr. Prisco, I will switch to English. First, I would like to thank IBRA for the invitation for the event. Our sector needs events like this. Every year, we have seen events which is growing very more robust. The involvement of all the stakeholders we have today in Brazil, driven by IBRA. It is a necessary event. I'd like to congratulate IBRA for this initiative and the great participation. We can see the number of people, how this is involving people. I'm going to make a brief biography of Dr. Priscu. I will pass then to English and interact with him.
Prisco is a co-founder
of
Prisco Geotechnical with Prisco and Associates consultant engineers based in West Vancouver. He holds a PhD in mining engineer from McGill University and is a registered PE from British Columbia. He has over 35 years of experience as a contractor, consultant, and then owner in the field of geotechnical and geo-environmental engineering related to the mining and water resources industry on 5 continents. He has been a tireless volunteer and a true supporter of many technical not-for-profit organizations, including CDA, MAC, SME, ICMM, iCode from Chile, and among others. He is the recipient of CDA 2023 Peter Halliday Award for the service and is an honorary member of both Romanian National Committee on Large Dams, Roll Code, and also a member of the Technical Science Academy of Romania as well. This presentation, titled Tailings Management is about water management, is part of this Cross-Canada lecture tour. As a former global mining waste and water management lead from Anglo American, Dr. Caius was based in Santiago, Chile, with his family, but he has traveled many times to Brazil, which he says it feels like a second home for him. So I do like to thank Dr. Prisco to be here with us today, remembering that today is a national holiday in Canada, so it's a great effort for him to be here today. And I would like to ask to the audience a round of applause for Dr. Prisco. And please, Doctor, feel free to start your presentation.
Thank you, Thiago. I just want to make sure you can hear me.
Yes, we can.
Okay, and I understand that we have interpreters. Is that correct?
Yes, we have.
Okay, so I'll speak a bit slower. And lastly, you can see my full slide. Can you see the whole slide?
Yes.
Okay, good. So we're gonna get going here. First of all, thank you, the organizers. I thank Ibram and Thiago for a nice introduction, and all the support staff in Ibram for inviting me here. This presentation is part of a series of distinguished lecture that was basically awarded to me last year by the CIM, and I'm taking this across many sections of Canadian Institute of Mining across Canada. And I think this is very much in line with what Ibram is doing, and what Thiago, you mentioned, is sharing knowledge. We all learn every day, and whether you have 5 years experience or 50 years experience, we still learn every day. So today, myself, a geotech engineer, I'm not going to talk about geotech. We're going to talk about a bit about water management, and the reason is because we have water, as we say, the culprit for many of the issues we had in the past with our tailings facilities. So this presentation across Canada, of course, is sponsored by CIMF, which is the Canadian Institute of Mining Foundation. And I've been presenting this to various universities as well. So thank you for inviting me. This is just a general outline where we're going to do some general comments about water management, just a few failures in the past and the role of water, the controls. We're going to talk a little bit, as well as with an emphasis on how we can improve, actually. That's why we are here. How can we improve, mitigate, and minimize water management risks? So there are some challenges with and opportunities with mining waste management and the water management within this. So the first fact, I would call it, is water is either too much or too little. So in a nutshell, nobody's happy. So if you have too much water, tailings managers don't like it, and mining managers don't necessarily like it. Exploration teams don't really like that either. But if we have too little water, process managers don't like it, communities don't like it, and the stakeholders are not happy with it. So, I put here a couple of numbers that it gives you a perspective in Canada and the world. And you can see in the world, you can have variations from the driest place on Earth, which is the Atacama Desert, where you get 5 millimeters a year. So basically, it's almost dry by the time it touches the ground. And the wettest place that is somewhere in Masinran in India, where they have close to 12 meters of rain a year. So that is basically 11,872 millimeters. So how do you deal with this? This is a Canadian map, just to show you very briefly, that goes from very wet on the left side here on Vancouver Island to very dry in the Arctic. Of course, we have to deal with communities, license to operate, but also water quality, which is the third dimension that is so important. The second fact is that water is everywhere, from foundation to interstitial to top of the tailings storage facilities or behind the dams. And you're probably familiar with this chart where it shows from classic tailings disposal all the way to filtered. So removing water is, of course, one of the goals, but there's no guarantee. And this is very important for everybody to understand. And I think many of you in the room would know we had recent failures of even heap leach facilities, tailing stacks, overburden stack. So just because it's a low moisture content, it doesn't mean risk is not there. We still have to manage it. This is an example on one of the facilities in Canada on the left side. That is a filter stack tailings facility. This is courtesy formerly Newmont Mining, a very nice facility, but still the efforts are there to monitor it and to inspect it and to investigate it regularly. And then the right side is it's a paste central cone discharge that even if you think paste, you still have, you can see in red, some of the embankment dams that you need. So whether you like it or not, there's still water in the blue color, and you still have dams to contain it. So we are not done with it. Also in the filter stack here that looks so nice, actually in the background, I'm not sure if you're going to see it, but there's a perimeter dike for the entire facility, and at the back there's a water pond and sedimentation pond. So we still need to deal with a lot of water in these situations. And I can't stress enough, on the left side you have the chart from one of the ICMM good practice guides, where it shows that basically from 1970 until 2015, so in 45 years, we tripled the production for global extraction of ore, tripled in 45 years. And this is just a summary of some of the tailings facilities that are in mostly in South America that are on the right-hand side. You see here the projected dam height. And you know, just a reminder for those in the room, these are 3 of the top 5 tailings dams in the world in terms of height. And you have in Lozada tailings facility, courtesy of Freeport on the left. You have Cortadera tailings dam, courtesy of Anglo American in the middle, and the Quebrada Blanca 2 on the right side, courtesy of Teck Resources. So just to highlight that all of these are approved to go over 300 meters. The first 2 are in Peru. The third one is in Chile. And the middle and the right side photos show starter dams. So what you see here are just the starter dams, which are between 85 and I think 110 meters tall. So with these are basically amazing engineering feats, and kudos to all the teams that were involved in designing and operating this. But the fact number 4 is if you don't have data, there's not much risk management that you can do. You know, this is a famous quote from Edward Deming, who was actually an economist. Without data, you're just another person with an opinion. So but we're going to talk today about data and the importance of it in water management. And of course, it all starts with the knowledge base, the information that you have, and gathering as much from concept all the way to closure and post-closure. You know, there's a lot of technology and data collection from site-specific data. We need to invest in instrumentation, build that knowledge base, right? We also need to apply the climate change models with caution because, to my knowledge, the last I checked, there were about 16 climate change models. Not a specialist in climate change models, but each site, each location, each geography is specific, and you need to select the right model. One model, for example, in the Andes Mountains at, let's say, 4,500 meters, you don't apply the same model as northern Finland or beyond the Arctic Circle. And these are examples of instrumentation that we need to collect, including the bottom right photo, which is basically evaporation and climate data collection system that is actually on top of a tailings facility. It's not nearby. It's not at the plant. It's not at the end of the property. It's on top of the tailings pond. Why do we need all this? Definitely, there's a lot of questions here that I put on the slides, but we need to think from the site-wide operational level you see at the top to all the way to the regional level at the bottom. So if you think about this, what you see at the top is actually at the bottom a very small portion at the region level. So water needs to be included in a regional water balance. A site-wide water balance may not be enough. And of course, calibrations and good quality data. Fact number 5, I'm not telling you anything new here, but I want to stress that there's a big gap noted in tailings professionals. I've seen some comments out there that it's not really true that we have enough people. I don't think we have enough people. And I would say as a former consultant, current consultant, but also a former dam owner, the mining industry is actually stealing a lot of bright minds and young engineers from the consulting world, and we are not solving that. We don't solve the problem. So we need more training, we need more specialized courses in universities, and we need also governments to actually recruit quality technical staff to help in this process. So we just want to spend 3 minutes on 3 key concepts that I've seen in my career. There's a lot of confusion: critical controls, operational controls, and KPIs, or key performance indicators. They are not the same. Definitely, critical controls are the ones that you want to look at when we are talking about dam safety. And it's a governance approach that is managing high consequence risks. You're familiar maybe with the bow tie approach for risk management. So basically, critical controls are defined based on the priority unwanted event. And you can have preventive on the left side here in blue, the blue boxes, or basically recovery mitigative controls after the event. And there are many examples in the world, and I'm happy to chat about them, where even after the event has happened, these are super critical to minimize consequences. Risk controls are typically designated as critical control if the implementation of the control would significantly reduce the likelihood or consequence of an unwanted event. So very, very important to understand what a critical control is. So you basically set up your management, your instrumentation, your trigger action response plan based on critical controls. Operational controls are not critical controls. So when somebody's saying, for example, your pond volume goes up by 500,000 cubic meters, that's an operational control. It's not a critical control. The dam didn't fail because the pond went up a bit. Also, KPIs do not relate to the dam safety in general, and they rather reflect the overall performance of the TSF. So I just selected a few. I'm not going to spend a lot of time because I want to go into the mitigation, but are we truly learning from past events? And this is a quote from the Irish writer Oscar Wilde, who has a fantastic quote, and I'm sure many of the academics in the room will have a smile when you read this, but experience is the hardest kind of teacher. It gives you the test first, and then the lesson afterwards. And it's very much true that we need to be ready all the time. Aberfan disaster in Wales with 116 children dead and 26 adults. You know that. I'm not going to talk again about geotech, but what was the issue here with water management? Site investigations were not properly done. The dump was sited over a natural spring, and together with a heavy rainfall event, that went straight into this small town, and there were a few schools there. This was a terrible event in '66. So importance of extreme rainfall events, but also quality hydrogeology, it's critical. This event, Stava, in '85, again, water was the culprit. Poor operational practices, poor pool control, incorrectly installed drainage pipes, and piping failure that basically was spotted but was not fixed. And unfortunately, this was 268 people that lost their lives. Mariesspruit, you may also be familiar with this one. In South Africa, 17 people lost their lives. Basically, before the failure, there was almost no freeboard, almost no monitoring. Heavy rainfall came and basically washed out. What's important to note is that prior issues were ignored. So it seems like the owner was aware of the limited freeboard, and nothing happened. And of course, you're familiar with Fundão, and my heart goes to all those that were affected by this. Again, that was another example of a lack of recognition of seriously of the emerging issues that were many years before the actual event. And of course, I have a couple of sketches here of, the original was supposed to be a low phreatic surface and no slimes here, whereas the right side, it was a high phreatic surface. So if we would have probably managed the water and the phreatic surface better, maybe things would have been completely different. And last but not least, just wanted to highlight Jagersfontein, again in South Africa in 2022. Very poor construction planning and expansion. And what's important is that the dams and the dikes were not designed to store water. And even though this was an old facility, the latest owners, you can see on the left side, the yellow shows the final footprint of the facility, and this was the original. What's shown in, it's in reverse here, but what's shown in green is there's almost no freeboard left, so very, very poor management. And this is the final footprint after the failure, where you can see the final footprint was actually touching on a downstream pond. So definitely something happened there where you have a wet toe, and also you expanded this with dams that were not designed to hold water behind. So what I'm going to show you now are real case situations from around the world. I know some of the mining companies in Brazil are up to speed with a lot of this, but I think it's important to share knowledge and to see what others are doing. And these are real case studies that I want to show you. Of course, data centers, surface water, monitoring seepage, operational controls, water balances, technologies, and critical controls, what to look for specifically. This is an example which is courtesy of Pan American Silver in Brazil, where you have a center. I know some of the other companies have similar centers, geotechnical monitoring center, but what's interesting here to highlight, you have the cross section in the background of the dam, you have the view, but more than that, you have in the middle screen, they have water management, the flows, the pumps, the weirs, the levels, equipment and pump status, even monitoring of the cyclone splits. It's automated and it's included here. On the right side in the blue screen, they have the critical controls, which are already plotted. and include water recycling rates and compaction levels and so on. So a good way to actually have everything at hand, including the water management, the tailings management, and the flows. This is courtesy of Codelco with permission. Appreciate that. This is one of the major facilities in Chile. Belongs to Codelco, one of the top 3 largest copper producers in the world. They implemented a T4G platform where all the instruments are coming to one center, both geotech and water management, and including TARPs with emergency level. And this is just a print screen of what they are doing and how they are doing it. Basically, these are the instruments and the type of instruments. And of course, the colors give you the idea of the alert levels. And the type of instrument is basically the shape of the data. Also, they included a historic data in this. And what they get on the screen, they get each tailings facility. This is Sobejeria is one, Piquenes is another one. And then they have trends for, I'm just giving you an example here, but this is from basically starts in March 2021, and I think it shows till end of 2023. So historic data plotting is because you want to see trends as well. This is also Codelco, where you have the actual cross-section of the dam, and very important, the actual elevations of the piezometers, the values. You have the plan view, and you can even include in this the accelerometer results. Sections here I mentioned in the slide, they need to be implemented as built. So not as a design said 10 years ago or 15 years ago, but the as built to be accurate. This is the example of Tech Resources in Quebrada Blanca and Carmen de Andacollo. They have a similar center for monitoring. This is 24/7 monitoring in the Santiago offices. They have a digital management system, and when we talk about water, basically the screen down here shows the gestión hídrica, so hydraulic management, so water levels, weirs, levels, freeboards, and so on and so forth. They also use 3 drones to fly over Quebrada Blanca 3 times a week, which allows for online bathymetry and topography information to bring it onto the dashboard. For surface water management, you can go from, it's important to manage that, to understand the pond management. The levels here, this is automated on this pier. The pier, actually, I just want to mention, it has deep foundation installation, so it's not moving anywhere. So you get the water levels. You also have the bathymetric survey automated, and you have the drone survey, which is automated, and you get these type of outputs, which tell you right away where your crests are, where beaches are, and how much tailings you have, how much water you have. And what's good about this also, the spatial data provided by iGlobe Group, it also has an input into the KPIs. We were talking about operational controls and KPIs. So it's not just the critical controls, but it's also other indicators, performance indicators are benefiting from this management for water. This is another way of looking at the supernatant pond. This is courtesy of Freeport-McMoRan, one of the largest copper mining companies in the world. And this is a very nice way, in my opinion, of presenting pond volumes and pond surface and where you are in terms of dam safety. So you have a dam here with a perimeter dike. The pond is in the middle, and what they do is the pond is analyzed for capacity to contain the 100-year and 72-hour probable maximum flood. Post-storm beaches width is analyzed in advance. So what you have here plotted, it's automatically generated as if there would be a 72-hour tropical storm PMP. So the lines in white and pink are basically the target minimum operational freeboard. So you always have, if you have, for example, the beach length being a critical control for you, like it's in this case, you have at every minute, or you can pull out this daily or weekly, and you can check where the beach is. And in their case, you can see that the 100-year, 24-hour storm is not, it's not even going beyond the operational minimum beach. And what they also do is the same pond, you can see here 3 different dates, July 28, October 18, and January. So what they do is they do it weekly, but once every quarter, they are preparing all these reports. And they always look at the beach width, which is one of their critical controls. Very easy and very easy to read and very easy to understand where you are. I find it very, very useful. The superintendent pool location, recon pond management. We know many times the pond goes in places where we don't want to. This is an example from courtesy of Photosat and a site in Zambia, in Africa, where the pond was here in 89 and then here in 92. And now they built a tailings facility around the last one with the pond here in 2020. So by having this information, historic information that you can obtain from satellite photography, you understand what is underneath the pond. You understand also where you put your dams. So you don't want to put them on a former pond where you might have very fine materials and so on and so forth. Today with satellite technology, you can go back in time and get some very interesting photography. Also Photosat, the same site, you can even show the beach length and location and the height of the dam, in different years. So I think the first one started 89 and all the way to 2000. So you can actually go back in time and see where was the pond, what was impacted or not impacted. And when you combine it with the bathymetry, you're getting very good control of the beaches and the volume of the pond. Operational controls, this goes, tech resources, this is an example of water balance model, predicted versus measured. Always check on both. Are you on target? Do you need to recalibrate? Are you having a realistic water balance? And this is a way to check it. And definitely, you can track that against your key performance objectives. So the alignment between site operating team and associated with the TSF, everybody speaks the same language. And of course, nowadays, bathymetric surveys are done automated, remotely and automated. So very easy to include this in the water balance. This is courtesy of Newmont Mining, where they have a KPI accurate interpretation and trends for various KPIs. Some are calculated and some are projected. For example, precipitation, processed water, pit water, raw water, and not only where they are at, but also the trends. Maybe you can see the arrows. So it's the value, but also the trends. So you want to understand what is happening. So they have a 7-day, a 30-day, and the current evaluation. And this is quite important for any reporting for ESG reporting, as you know very well. Anglo-American water balance, this was an example where what they did is TSF water balance was not needed to be assessed together with everything else at the site. And this is an example of a return water dam that was designed at the same time with the tailings storage facilities. And the two were talking to each other, and they were incorporated, both of them, in the site water balance, not just the tailings facility. So it becomes a much better design and more robust. For seepage, thermal imaging is becoming quite popular, and we know seepage and internal erosion is a big challenge for everybody, but infrared technology to detect heat emissions from various objects is quite used in multiple industries, but now also in mining. And Newmont Mining were kind enough to share this photos, and these thermal cameras can be mounted on drones, and you can actually spot here, for example, the bottom photo is a regular drone footage. You don't see anything. But when you look at the infrared one, you can see here maybe where my mouse is, and there's a black dot. Anything that is dark purple or dark red, it's wet, which you wouldn't know if you were here. I'm just using a regular drone footage. The same thing here. This is in the Arctic. Very interesting photo that you wouldn't see otherwise. So the picture on the left, it shows the minimum temperature is minus 17.1 Celsius. And the thermal camera picks up a 7.6 Celsius here next to a dike. This is one of their dikes. So if you fly over this, you will not be able to see this. On the right side, the same as in a different color. So these can be mounted on drones today and can help you at least catch early if there's any issues with major seepage or exfiltrations. Fiber optic has been used successfully, and Anglo installed this in one of their dams. On the left side, an existing dam for large strain and temperature monitoring. That was an old tailings facility. And on the right side, underneath the liner for a new facility, also for strain and temperature. And basically, this temperature differential will actually highlight a seepage if you have an issue with the seepage. Last but not least, multispectral analysis. This is coming very strongly in our field of practice. So basically what it is you get moisture content and saturation levels using this infrared wavelengths. And what you get is basically areas that are high moisture or low moisture, or where the pond is. You can see pond, beach, and so on and so forth. So you can actually monitor your tailings management. You can check back, where did you deposit the tailings the last time? Did you deposit in the right location? How much humidity do you have in the beach, and so on and so forth. This is really useful for day-to-day operational management for tailings facilities. And this is courtesy of AAN. So, of course, there's multiple geophysics methods, but we're not going to have time to go through them. But anything from seismic refraction, electrical resistivity, tomography, distributed acoustic sensors, very popular, ground electromagnetics, seismic profiling, magnetic resonance. Just, I think I would urge anybody in the room to put together a white paper on all geophysical methods related to water management in tailings storage facilities. There's so much to share this knowledge. Of course, we need to learn from mistakes of others, because we don't live long enough to make our own mistakes. So I'm going to conclude here, Tiago, with a couple of slides. I learned that Mother Nature will always win, sooner or later. So don't try to stop water, rather control it and work with it. Water is and will be omnipresent in and around our facilities. If you think filter tailing stacks are the panacea, are the best solution out there, they still need very close monitoring and evaluations, because risk is never zero, actually. Heap leach facilities, the same waste rock dumps. We've seen high moisture content in waste dumps of a finer rock fill. They had issues. Even if mining goes, let's say, to waterless processing, which we hope one day we're gonna see, we still need precipitation management, climatic condition, ice formation, groundwater, seepage, aquatic geochemistry. So we are not actually ending water management, and other industries are going through the same issues. Be aware and read, learn, train, mentor to better implement, have the right staff, the right team, and avoid falling into the trap of poor governance, which is basically ticking boxes. So my personal message to you is quality data for water management and instrumentation. Start early from concept level and build on your database to reduce uncertainty. Build a more robust design. If the minimum required is X, maybe you do it a bit more. Follow leading practices. Don't save money on investigation. We've seen some examples in the past, including the one in Aberfine where that was a disaster. That's not where you save the money. Design criteria aligned with leading practices, and OMS operation, maintenance, and surveillance manuals always set up the roles, responsibility, control, critical controls, and reporting protocols, including water management. Sometimes we are focusing too much on the geotech and we forget that water is the one that we need to deal with in the first place. Last but not least, train staff. Explain the risk to the staff, and they will be more committed and more interested to do and take care of what they are being done. Don't just give them a task. Explain to them why is that task, how important it is, what are the challenges with that task, and what happens if it's not completed. Of course, implement external reviews. External reviews, you know this, but this bullet here, third from the bottom, elevate issues, concerns, and risks as soon as possible. For anybody in the room, and especially the younger generation, especially the younger professionals, please, please, please elevate the concern to your supervisor. Do not just hide it. Do not just cover it up. Do not think that it's going to go away, because it's not going to go away. And you know what? Have that courage to go to your manager or in the meeting to say, hey, I saw something that is not right. Can we have a discussion about it? Because many of these dam failures that we discussed could have been actually almost all of them prevented. These are the companies that provided me with this information. These are real life examples, and I want to thank everybody for the time, and I'm sure we have some questions, and I'm happy to have a discussion. So, Tiago, back to you. Muito obrigado a todos.
Well, Dr. Prisco, it was a comprehensive presentation covering most of the key aspects that we must look after a correct tailings management. I think that we can start with some questions. We still have some time to do it, okay? And I will start with myself. So what I want to ask to you, Dr. Prisco, was one of your first phrases here during your presentation was about that false sense that reducing moisture content will ensure safety on your structures. And here in Brazil, we are looking to change to filter stacks, drainage stacks, we can call it whenever the name it is, but the piles that we are looking with filtration, with dewatering, and also the previous dams that we have. After 2019, in Brazil especially, we have been putting a huge effort applying critical soil mechanics in our structure, putting the state of art in geotechnical to better understanding our structures. But nowadays, when I've been talking to other colleagues, I've seen that a new trend will emerge soon enough, that is the unsaturated.
Yeah, so first for everybody, so we are on the same page, it's excellent to dewater the tailings. There's no question about it. My point is, just because you have filter tailings, risk doesn't mean it's zero or close to zero. So we still need to monitor carefully, because what's happening, Thiago, in general, especially when you go to high, the height of the stack on the pile, in the middle, you're gonna have accumulation and increased moisture. So you're right, unsaturated soil mechanics is gonna be critical. If anybody thinks that at the bottom of the pile is gonna be dry, that's not actually true. So one thing that I want to highlight is the University of Saskatchewan in Canada that had pioneering in unsaturated soil mechanics, and many of you might be aware. There's a couple of books on this topic, and I can provide you the information. But definitely an important topic that we are not talking enough in our universities. There's no question about it. So yeah, I think one of the fathers of unsaturated soil mechanics was actually at the University of Saskatchewan many years back. So, but there is a very nice book on the topic.
Thank you so much. And just a reminder for the audience, I've just received a couple of questions here. If you want to make a question in Portuguese, I can translate it to Dr. Prisco, okay, guys? So don't feel shy. But I will start with a question that Rodrigo Machado raised here, Dr. Prisco. During your presentation of the failures, the event that we had in the past, why you didn't put anything about Brumadinho?
Listen, there's nothing specific. Because of the time constraints, I put certain things that were, 5 examples. Time allows me only for 5 examples, so I wanted to give examples from around the world and in different locations with different reasons why water was a culprit. Of course, Brumadinho is very important, and it's a big lesson to learn, but I didn't discuss about many others, right? I didn't discuss about Mount Poli. I didn't discuss about Australia. I didn't discuss about the major failure that happened in Turkey or in northern Canada. So it's just a matter that I limited time, nothing else. But definitely, as I mentioned, I'm very respectful and very much humble when I talk about these events, because we need to learn, but not only to learn, take it home and implement those lessons. So it's just a matter of time constraints. I can only spend 40 minutes in this presentation. It's no different than geophysics. One can talk about geophysics in tailings dams for 3 hours, I think, or for a full day. So I had to choose some examples.
Thank you. Next questions would be from Gabriel Negrini, asking how do you see the role of private telecom companies networks with technology 4G, 5G, Wi-Fi, LoRaWAN, particularly in reducing emergency response time and enhancing risk management here?
Well, obviously, I'm not an electrical engineer, but my understanding is that you will definitely be part of solutions at the operational level and beyond the boundaries of the property. So there's no question that we are moving maybe away from radio, or we keep radio for some of the instrumentation, and we are increasing the cell coverage. I know I can tell you personally, living in British Columbia in Canada, I'm getting warnings on my cell phone all the time. They are basically automated warnings, and most of them were, how should I say, practice warnings about either a heavy storm or simulation for an earthquake. As you know, British Columbia, Vancouver in particular, is expecting a big earthquake. Who knows when? Even I'm living in an area with a lot of wildfires. So, this cell phone and communication process is pretty important because we all get the same message at the same time. So 100% a big part of the emergency response and preparedness. There's no question about it. So, and thank you for highlighting that.
Yeah, for sure. It was a great question. Moving from the future stacks, Dr. Prisco, Maria asked, what would be the critical control that is being applied, especially regarding water management to those structures in superficial waters as well?
For which structures? For filter stack?
Filter stacks, yes.
So obviously the number one is drainage control. It's absolutely critical that you have proper drainage and you measure that drainage. I've seen situations where you actually have drainage by area or by zone or by deposition area. Secondly, you can have definitely deformations, which could be a critical control. So once you get your moisture and you have your simulations, you're gonna be able to see that, and you probably have seen around the world that deformation analysis are in many situations taking over the slope stability analysis. We still need slope stability analysis, but deformation analysis long-term are gonna be the key. And then, of course, based on the above, in situ densities are a key control, moisture content, a key control, phreatic surface. And yes, there is a phreatic surface in filter stack tailings, and I've seen it with my own eyes where things are going up, and it's not a good thing. Once you build it, that's it. You can't just go and excavate it, right? So you have to manage it. So I think that's important. And then the last point I want to highlight, in order to minimize water impacts on a filter stack, always think about how you're going to close the facility and close a portion of it. So you can actually cover a portion of it so your water is going to shed away from the structure, precipitation. So you minimize the infiltration rates. So, in part of the operations, you're going to implement your slopes, you're going to implement your compaction, and you want to shed as much water away from you. But part of the equation is to have a good understanding of the closure plan and actually try to do progressive reclamation and cover portion of it as you go. And the example that I gave you from Newmont in Canada, they actually covered, I think, 1/3 of the filter stack at that time. So only 2/3 were actually exposed and operating.
Yes. So to summarize what Dr. Prisco says, I think.
And sorry, just to add, always you will need a perimeter dike. There's no question about it. You need to control the water. So superficial waters, you want to measure it and control them in the pond. And the drain system underneath it, you're going to measure it in another location, and you get definitely your proper water balance. Yes. Sorry about that.
No problem, doctor. So I would like to highlight that a reflection, an insight to everyone. Are our design robust enough, considering that those were scenarios? Phreatic surface in the pile, progressive closure. So I think we have an opportunity to reevaluate some designs, because after build it was, as Dr. Prisco says, we couldn't done anything more after it was built. But moving forward, 2 questions in a row. $1 million question, Dr. Prisco, was about climate change and what your thoughts on it impacting our structure regarding water management as well. But how do you see climate change impacting us in the future?
You're right. I wouldn't be here if I knew the answer. Okay, but no, honestly, and I know some people will agree with me and some people will disagree with me. Again, I'm not a hydrologist. I'm not a climate change specialist, but what I have seen and evaluated, if you design to extreme events, okay, so whatever you choose, the 24-hour, 48-hour, 72-hour PMP, the climate change that I've seen, and I've been in many review boards around the world, there's very little impact on that. Where the impact is seen is mostly in the 1 in 50, 1 in 100 return periods, 1 in 200 return periods. So maybe you need a bigger contour channel. Maybe you need larger drains. You know, you were talking, Tiago, a few minutes ago about drains. Leading practices, you take the maximum flow possible through a drain and you multiply by 10. That's a leading practice for a drain design. It's a factor of safety of 10. Maybe we need to make it 12 or 15, but in terms of the actual value of an extreme rainfall event for design purposes, I have not seen big differences. So I'm just pulling out an example, right? If a site has a 24-hour PMP of let's say 1,000 millimeters, applying the climate change model may actually get it to 1,050 or 1,100. I have not seen anything yet that will increase it tremendously, like saying 50% or 100%, right? Unless the original was not properly calculated. But what I've seen is the lower return periods are actually changing more often. The 1 in 20, 1 in 50, 1 in 100 year return periods. Those we need to be a bit more careful with. And it's always good to have a bit more robust design, right? I've been to a site actually. I'll be honest, one of the sites in Brazil, and I'm on a review board, and leading practice might be to design contour channels at 1 in 100 or 1 in 200 year events. They design it for 1 in 1,000 because they don't want to have any issues, and so these things are up to the owner and the design team to make sure that there's a robust just because somebody is saying 1 in 100 is enough doesn't mean you design for 1 in 100. Think about a little bit of extra money invested may actually reduce tremendously the risk. So where is that value added in the design?
Great. Unfortunately, we are running out of time. We have a couple of questions here, but I will leave it here to be answered later, okay? I would like to thank Dr. Prisco for this presentation, and I will pass to Marcília for the closing. Thank you so much.
Thank you very much. I really appreciate
Thanks,
that.
Dr. Prisco. Obrigada, Tiago. Vamos só posicionar para fazer uma foto, por favor?
And I'm sorry I was not next to you, and hopefully you're having a great event, and I know for a fact that IBRAM and all the mining companies in Brazil are really, really pushing hard to share knowledge, and this is fantastic. So congratulations on, I understood it's a great event with almost 400 participants, so congratulations to IBRAM and all the sponsors.
Thank you, Caio. So for the last photo, let's give us a smile to everyone here to take a photo, okay?